Hi, everyone. My name's Stephen Hilt. I'm a senior threat researcher for Trend Micro. I work in the forward-looking threat research team. And what we do on that team is e-crime investigations, APT investigations, and general research as well. So this falls under the general research category, but we take a different approach when we're looking at devices like this and how criminals might be able to use them. So this all started out as kind of a personal project because I actually ended up deciding this was going to be a great gift for my wife for one of her birthdays. And it was between the Bose and the Sonos. And I ended up going with the Sonos, so most of it's focused on that because the one I had was a Sonos over the Bose system, which is equivalent even in price, all around $200 US. That's the Sonos One on the left for you, and the Bose Sound Touch on the right. It's the Play One, not the One. Sorry. Sonos is since I built and did this project, Sonos released the Sonos One, which is built in with Alexa. So they're common choices. As I said, one of the first things I always do when I add something to my network is I in-map scan it. This is what it looked like. I recommend everyone doing this. If they don't, you should. I noticed some quick things there, port 1400, 1410, 1433. I'm a researcher, so the first thing I do is actually Google things. So I started seeing if there was anything out there that existed previously for Sonos, and somebody actually had already written an Nmap script. So once you download the Nmap script and run it, you get all this information. So then I was like, where is it pulling all this information? And when you start digging into it, into the script itself, it pulls from port 1400/status/ZP or ZL, depending on the device itself. So then it's parsing that information. And then what we did was I ended up traversing back a directory, and that's the status page. And you can see a bunch of information in there, such as UPnP status, API status, cloud. Track summary actually gives you what's playing currently. Then there's the track queue. The ZP, as mentioned, was where that information was populated. A topology. So these things kind of can communicate together and play the same song. The more you have, that lists every device in there. Controllers are the devices that are controlling it. Shares, so if you have any SMB shares, FTP shares, or anything like that you've pointed it to, it's all listed there in the contents of those directories. Alarm, if there's an alarm scheduled, such as you can set one up to play a sound at 6 a.m. and wake you up. There's also the play mode that depends on if it's playing, what it's playing. But the interesting ones as you start going down is there's accounts right there. Accounts, and then there's a bunch of other stuff that it doesn't show up on this screen, but we'll talk about them briefly in a little bit, because that's where I got a lot of the information was from accounts and another page. They had this really, really neat page. If you go to /tools/htm, and those look really, really juicy. So I played around with them for a little bit, and this is one place I actually did really well on security. So I couldn't really get anything out. One of the best things I found was you can actually do a broadcast ping. So when you find these things that were on the internet, some of them are natted through, and if you do a broadcast ping, you can start mapping out the internal network. Then if you go back, there was, not on that page, I don't think, there's actually the ARP table you can pull, the ifconfig, the net stats, everything that's running on that box, more or less, there was an option to pull that information. So that was fun. What we did then was we started looking for a better, yeah, that was the broadcast ping. I worked with John Matherly at Shodan, and I started incorporating with that Nmap script. He scanned it for us. This is a couple-month-old picture here, screenshot, and there was roughly 4,000. At that time, at the highest point was a little over 5,000 devices. We're hiding a bunch of the information, but if you actually have an API, you can actually see all the API, all of that information that the Nmap script's getting is in the API, so you can actually pull it. So once you do that, if you have an API and can pull the information, we can start parsing out the information. So this starts telling you the numbers in which of what devices are the most popular. Confirm that I bought the most popular one, so that was nice. There's actually 2 different versions, and we'll talk about that in a little bit. Older Sonos Play 1s were PowerPC. The newer one's an ARM chipset. Interesting thing was this was taken right after the Playbase was released, and there was already 16 of them exposed to the internet, like within 2 weeks after it being released. So once we started populating that information, again, you can kind of see the most popular countries. United States being the highest, and then Sweden, Belgium, Norway, and Canada, because the potato quality of that screenshot. So I didn't want to just leave Sonos and feel like I'm attacking just them. So what I ended up doing was I started figuring out how we could identify the Bose without actually owning one. So this kind of shows you kind of the same techniques and concepts, but they run on port 8090 as their API, and it comes with a header, more or less, of Allegro software ROM pager. So, and there's less of those exposed, and again, it's the same countries. You see United States, Belgium, and Sweden in there. Interestingly enough, Korea and Taiwan populate in there, because Sonos, I don't think, are actually released in those countries. They have the exact same problem, and Sonos has the same problem. So this is the Sonos here. This is just some information leakage. So if you go under the topology, as I was mentioning earlier, it says the zone players, and those are the 2 devices I have in my house at the time. There's more now. And then there is the list of all the devices that have ever connected to it. So you can start figuring out, like the names of the phones. We were looking through them, and you know how people don't change their default name of their iPhone, and it has their first name and last name, or just first name, and the UUIDs and all this information. So you can start figuring out kind of even what devices they may have plugged in and what they have themselves. What would be really nice, though, is not just name, but if I could really try to start identifying that person, such as in the accounts page, where it gives you their email address. For this one is specifically for their Pandora account. And so now I have an email address, I know what phones they use, and so on and so forth, so we can start piecing some of that information together. Started looking in the Bose as well. Once you start pulling into their API, it's the same information. So this is a Spotify account, and this is their email address for their Spotify account. In this one, you can also see how how it's the main connection. So you see, where is it? Aux is the source. There's Bluetooth, and a couple other ones that are listed there, and how it's actually being played, whether it's over the phone that's connected to it via Bluetooth, or if it's through an aux port, or if it's being done over Wi-Fi. So then I started looking in the Sonos, and I found this page called Scan Results. Scan Results turned to be very, very interesting, as it's the the wireless scanning results from ATH config, and populates any of the neighboring Wi-Fis that it sees. This is used during setup, so it can tell you which one around that you want to connect to. This is was being left on, and you can start collecting information. Then I found a really neat API from Alexander Malinkov, and all you have to do is feed it a BSS ID. You set the data source to all, instead of, by default, his example has open, and you can start populating. He collects a bunch of the Wiggle and a bunch of other APIs and pulls them together to his, so you don't have to do multiple requests. And so once you do that, you get the latitude and longitude. So what we decided to do then was that example here is populate it where it is on a map, which is, fairly common thing to do here. And so that was just one of those BSS IDs from the previous screenshot. It's in that location. So what we did then, we started populating, and what I did was take all that information from Shodan, scan all of these pages, and then run a lot of API queries against this, and made a map of more or less where all the BSS IDs that were seen by the Sonos and where they are based off of that API. So you can start getting some information such as clusterings of information here. So you can start kind of figuring out roughly where the device is. Does anybody know where this is? Huh? Well, the next screenshot shows us up there in the top left. It's very close. So you can actually walk over there and see these SSIDs today, and somebody has a Sonos in that area. So what we decided to do then, based off of those clusterings, that doesn't tell me who it is or where exactly the Sonos is, but I know it's roughly in this area. So what we decided to do then was do a case study where I could start seeing if we could positively identify that this information was accurate, that there was one in that area. So knowing the US better than most other countries on how they do their data, I started looking. So I filtered down to the state of Colorado, mostly because I don't live there and I dream of living there someday. And then we took the information and populated it on the map as previously. So that's a good clustering of information right there. If anyone was to guess, possibly you got any ideas where that thing might be? Now there is some information also in the API. You can start individually populating these and then start looking at, because it actually records the RSSI, so the signal strength. So if you start looking at that, the good clustering's right in here. So again, bad quality of that picture, sorry. So then once I started, and some of this stuff has been masked because this is a true person's identity. So you start looking into the accounts page. I was able to get an email address that I blurred out, and I get a guy, 46 years old, and blurred his face and all that other stuff. We've contacted him. He was well aware of this stuff and has since altered his security on these things. So then based off his name and using some public information, I was able to see current and past addresses. So mentioned 6654 there is the current address. And once we map that to where those are, 6654 Blank Street is right there. So it was a little off. I said it was probably right around in here, but wasn't far off. So that was validation that based off of this clustering and then some open source intelligence, we're able to find out who it is that owns this device. Okay, what can we do with that? Well, there's not a lot, but you can have fun and realize that he really likes hair metal. And if you keep pulling that information, you can see what kind of music he actually likes. And you can keep going through that, and then we can start building kind of an attack profile of what we want to do, and I'll talk about some attacks here in a little bit. So that's very interesting, but that's the Sonos. So does that exist on the Bose? Yes and no. It's a little harder. Bose setup page looks like this. And so there's a drop-down menu, and you only get the available SSIDs. Luckily for us, we can also take that and then populate it into Wiggle. And the more you have, the more information you can get about where it is. So yes, it does exist. Not as nice, a little more complicated, but it's there. And we can do the same on the Sound Touch. We can pull what song. this person on this random one was listening to Eagles, Lies, Lying, and the Bose API actually, in one request, will actually tell you the source, so I know they're also listening to Pandora. Now, one of the fun things I thought would be really neat, turned out to be a complete flop, was after one of the major artists recently died. You know, everybody knows Tom Petty. Tom Petty died. I wanted to see if there was a spike of people with their devices exposed to the internet who started listening to Tom Petty. No. Didn't happen, so can't put that slide in there. I can only tell you we tried. But you can actually start pulling this information. One of the things that both vendors and a lot of other vendors in the IoT space are going with are open APIs. So as you've noticed, there's been no authentication to get any of this information. They want to be open so many devices just can talk to them without a lot of exchanging and setup. Just be able to, you know, they're really nice. You can just point your Spotify account to it, log it in, and everything works. Or your phone, you can just be like redirect it to the Sonos or the Bose, much like Chromecast works in the same way. But the interesting thing is that because it's open, you can sit there and pull this information. So how long before people start using this information on the exposed ones to start possibly, you know, changing things? And I actually had a conversation last night with a gentleman here about this. And he had a really good point as well, which is if you take this information and you can also adjust the settings, like turn the volume down, and then start playing whatever tracks you want as like an advertiser to boost your metrics of those songs. That's a possibility because you can, as I'll show in a minute, you can just make it play any song you want as long as it's hosted somewhere. So we started looking around as well to see if, you know, anybody else had found these kind of problems or anything like that. And there's this GitHub page called Ghosty. So there's a GitHub page for this project called Ghosty. This is actually a Sonos forum where somebody was complaining about they've had a Sonos system for 7 months and it's just randomly playing sounds like a ghost or a creaking door and things like that. There is actually a GitHub page. I didn't share in this one, but if you just search Ghostly, it's a Python script that at random intervals on a specific IP address will play a creaking door or a ghost screaming. And as she mentions that they have a baby and it's upsetting them. So that led me to look at the project Ghostly. Ghostly hosts an API through a simple web server and just says, play this song. And it's literally that simple. It's got timers and it goes, host web server, play this song off my web server. So what I did was I wrote my own version of that, only running an Alexa command. So I have a real quick demo of that to show you just kind of how you can play any song you want if audio works. No? Dang. No, volume's up. Let's try it again. There we go.
Alexa, what time is it?
It's 3:39 p.m.
So very basic, just asking what the time was, but kind of shows you that if there's an Alexa nearby, it recognizes a computer-generated voice and does what it asks. Interestingly enough, I haven't tested it, but I believe this would hold true because in the Sonos One, the Alexa is a different board on the top with a microphone than the speaker, so they're separated systems that you can actually just talk to itself. It works on Google Home as well, unless you've put voice authentication on. Then it doesn't. But that's a different story and different research projects that other people are working on as well. And you can look those things up. But just imagine just things. We actually did this at the Trend Micro hosts a CTF. There's an online qualifier, and then the final is in Tokyo. One of the challenges I did was actually this. and it was to get some information from a special skill, but you had to go and tell the Sonos to talk to Alexa to get the information out of Alexa. Just kind of to prove that point that you can actually go several levels down and not just ask for what the time is. So imagine if somebody had Alexa hooked up to a smart lock and you knew where their house was, and you knew that the Sonos has a high probability of being near their Alexa or its one device. Then you could, in theory, ask them to unlock the door. Because they have it exposed online, you just send the request to that command, say, Alexa, unlock the front door. Front door gets unlocked, you walk in. Bose suffers from the same problem. We didn't ever tested this because that wouldn't be right, because I didn't own one. But they have there's a Python library called libsoundtouch. I was actually using it to pull what was playing, but not ever writing to what I wanted it to play. But it's the same concept, you just point it to an MP3. So then I started digging around a little bit on these open APIs and started playing with information. Here you can see this is the next command. So inside the web app, inside of the application, I hit next. It's all in clear text. There's some interesting fields in here I just started playing with. More or less, I captured a packet, replayed it. There's the packet. Just didn't hide anything from you guys. Just there's the packet. Send it again. Track skips. So then I started playing with some fields in it. Inside of this request is an IP address and a UUID. It's called the Rhinecon in their examples, so I just kept with that. So I started to fuzz a little bit on that field, and it took like one fuzz attempt to realize that if it's not about, like it has a special character in it or any other encoding, it crashes the device to where it needed to be rebooted. And the reason why I started playing with this also was because if you try to control somebody else's by this method, it won't control it because it's actually looking for its own UUID and goes, that's not me, and doesn't do anything. So there's a little bit of smart, except for they didn't do any input validation, so it crashed the device and it needed to be rebooted. So what I have here is an example of that exact same thing going on. What you see here is the next track script that I wrote originally, and what it should do is bring up the next song in the queue, listen to some epic sax guy, and of course the next song I will be listening to is Rick Isley. So the next one I'm going to run here is the actual exploit itself. And just like that, it literally takes no time, the device ends. So one of the thoughts we had for an attack scenario on this was, so I know I can play a song, and I know I can crash it. So what happens if we crash the device? We know that they were listening to it, so they're probably going to try to figure out what's going on. Then I know their email address, and then I spearfish them with a link that says you need to update it. And then I actually play that sound, a song, but a voice of saying that this is Sonos support. We realize you have problems with your device. We have sent you an email, follow the instructions. Now, a lot of people believe, like that's going to the next level, in our opinion, of where a good phishing attack would go. Because, somebody might be like, I don't click links. But if your speaker started telling you to click the link that came to you, you'd click it, right? No, we wouldn't, but a lot of people would. So that was one attack scenario. The other ones being, just more around the open source intelligence part and looking into identifying the person and using that information to help do phishing against them. Or this was just one simple attack. I didn't do really hard shakeouts of their APIs. And again, I didn't look at the Bose. So we have that. And then I got really bored one day and just decided I was going to take it apart and see what happened. Because I do dabble in hardware, I'm not an expert, so if anyone is and I see glaring things that I did wrong, let me know. We can talk afterwards. So a little close-up, it's got a WinBond NVRAM. It's running a Freescale microcontroller. So of course the first thing I did was go really hard and try to probe the V's with a needle, and I had a logic analyzer. I used a Soleil Logic Pro 8. That led to nothing. I couldn't really get anything, mostly because it's very small, it's hard to do, and probing 8 things at once is not the easiest in the world, so I moved on. I believe that was a UART, so probe that out to be a UART, and all those pins are dead. So it's deactivated, so that was a disappointment. Next was this nice 10-pin JTAG. That's what it looks like. There was data on it, but I could never match it to being any kind of JTAG that I knew about. So if anyone wants to see those captures, let me know. The other one was if you remove the Wi-Fi card, which is right here. Which, has anyone ever taken apart something that was musically sound for this stuff? There's hot glue everywhere and foam everywhere. It's a real pain to get apart. Do you know why? So it doesn't vibrate. Yes. Makes sense. I had this one here, sounds like crap now. Because I think I'm missing 3 screws. When you turn it up really loud, air blows out the Ethernet port. So I just put some electrical tape over that, and it sounds a little bit better. Just don't go above 50% volume. This was one of the best ones we found. We believed it was an SWD interface. And everything, even with the Soleil, it even said it was SWD with data. And sweet. All right, that's cool. I happen to actually have an STM32F4 Discovery. And so once I removed the CN3 jumpers, which makes it from to a Discovery board, it didn't ever find anything. So no matter how I pinned it out, no matter what I tried, I could never get it to interpret it as SWD. So if anyone else has any ideas on that, let me know. So what we did then was we just turned it over to Sonos and said, here's our problems, here's what we found, all that other stuff, and they fixed things within a week. They started pushing updates. The neat thing is, prior to this with Sonos, I had actually, they made an update, and people were upset because one of this updates, they said, if you don't apply this update, they're no longer going to guarantee things work anymore. And so because of that, one of the things they did was started doing remote updates that had to go through. So what happens was all of my devices that I had plugged in at the time got updated a week later automatically. And this is what the status page looked like. All the stuff's gone. That's pretty cool. So then I was like, wait, did I fix my exploit? Yeah, I get connection closed now. It's actually interesting. They send a HTTP reset, more or less. I don't remember the exact status code, but it's saying that function is no longer is not valid. So they're parsing it and saying, nope, you can't do that. So I've played with it. I've tried to get it to work again. I've played with other fields, and they apparently took our advice and fixed the problem. Because we didn't have anything hard on Bose, they responded to us and more or less said that with open APIs, and Sonos said this as well, that the API pieces are not fixed. You can still query information and those things. The accounts page on the Sonos as well is they've masked that so you don't see an email address anymore. I don't know about Bose. So Sonos is actually taking this it pretty seriously. One of their responses was the great one of we didn't expect these things to be exposed online, as no one does, but somebody out there will do it. And so as of Monday, before I flew over, I ran information and showed Ann we're back over 5,000 Sonos devices and around 1,500 Bose SoundTouch devices. If anyone has any questions, let me know. That was a really cool graphic I found. It's like, wow, that actually applies.
Yeah, I have one small question. Do you know actually why so many of these ports end up on the internet? Is it UPnP?
So there is UPnP that is enabled by default, and you can actually see UPnP mapping. So a lot of devices are getting exposed via UPnP. But honestly, I did actually do a query of that to see how many devices were a publicly addressable space, and a lot of them are just on the internet.
All right. Okay.
And I think a lot of the problem is, like you get cheap routers, you can actually flip it into just being able to get an IP straight from the ISP, and ISPs aren't limiting one connections to one IP. So a lot of the devices, like the device in Colorado, it was behind a Wi-Fi because it was on Wi-Fi because you can see if the Ethernet port's active or not. So it was on wireless, but the guy had 6, and each one of them had a separate IP address.